Welcome. In this video, I'd like to share another imaginary example in which a researcher is interested in testing the effects of two separate independent variables on one dependent variable. This time, I'd like for you to imagine a situation in which a researcher would like to test the effect of study hours on exam performance and also test the effect of sleep hours on exam performance. In this type of a situation, there are two options available to the researcher. And you might remember what they are from the last section of this video. In this type of a situation, the researcher could run two separate experiments. So the researcher could do one experiment to test the effect of the first independent variable and another experiment to test the effect of the second independent variable. In this particular situation, the researcher could do one experiment to test the effect of study hours on exam performance. And in that experiment, one group would study more, one group would study less, and the researcher would reach a conclusion. And the researcher could do another experiment to test the effect of sleep hours. And in that experiment, one group would sleep more and one group would sleep less, and the researcher would reach a conclusion. So basically, experiment 1 would lead to its conclusion about study hours, and experiment 2 would lead to its conclusion about sleep hours. And that option is completely valid, but there are some disadvantages to that option that I'll get to in just a moment. The second option in this type of a situation is to run something called a factorial design. And you might remember from before that a factorial design is an experiment with more than one independent variable. So if this researcher decided to do a factorial design, what this researcher would do is take those two separate experiments and combine them into one. And the researcher would do one experiment to test the effect of study hours and sleep hours on exam performance. So like I said, in this situation, there are two options available to the researcher. The first one is running two separate experiments. The second one is running a factorial design in which both independent variables are included within the same experiment. And right now I'd like to get into the advantages of this second option, which is running a factorial design. And some of what I'm going to say might be a review from the last section of this video, but some of it is also going to be new information, or at least some new vocabulary added. So if the researcher decided to run a factorial design, the researcher could arrive at more interesting conclusions, more specific and more interesting conclusions compared to if the researcher had run two separate experiments. If the researcher had run two separate experiments, all the researcher could conclude is whether studying has an effect on exam performance and whether sleep has an effect on exam performance. If the researcher did a factorial design, the researcher could actually look at specific combinations of sleep and studying and actually decide whether the effect of studying depends on the level of sleep. The researcher could actually look at whether studying is more effective with more sleep and less effective with less sleep. And the researcher couldn't do that by running two separate experiments. So in a factorial design, the researcher actually runs all possible combinations of the first independent variable and the second independent variable. So in this particular experiment, imagine that the researcher is interested in testing 0 hours of studying versus 10 hours of studying, and 0 hours of sleep versus, 2 hours of sleep versus 6 hours of sleep. So like I said, 0 and 10 hours of studying and 2 and 6 hours of sleep. So the researcher has 2 levels of studying and 2 levels of sleep. This researcher would run all 4 combinations of those levels, because 2 times 2 equals 4. And the 4 conditions in this factorial design would be 0 hours of studying with 2 hours of sleep, 0 hours of studying with 6 hours of sleep, 10 hours of studying with 2 hours of sleep, and 10 hours of studying with 6 hours of sleep. And like I said, in this experiment, the researcher could look at whether the effect of studying depends on the level of sleep. And the researcher could do that by comparing 0 and 10 hours of studying for the people with 2 hours of sleep and then comparing 0 and 10 hours of studying for the people with 6 hours of sleep, and looking at whether the change in exam performance from 0 to 10 hours of studying is less of a change when it's 2 hours of sleep and more of a change with 6 hours of sleep. And if the researcher did this factorial design and actually found evidence that the effect of studying depends on the level of sleep, you would say that the researcher found something called an interaction. And that's the new term I'll get into right now. So an interaction is a result in which the effect of an independent variable depends on the level of another independent variable. And an interaction can be found in a factorial design, but it can't be found by running two separate experiments. And that's really the advantage of a factorial design that I'm trying to get at here, is that in a factorial design, you can look at whether an interaction exists, but you can't do that by running the two separate experiments. And now I'd like to go I'd like to break down this concept of an interaction because it's a little bit of a challenging and complex concept compared to some other concepts we might have learned before. So an interaction, like I said, is a result in which the effect of an independent variable depends on the level of another independent variable. In other words, it's a result in which the effect of an independent variable changes across the levels of another independent variable. So if the effect of study hours changes across the levels of sleep, then the data is showing an interaction. If the effect of studying changes when you go from 2 hours of sleep to 6 hours of sleep, you would call that an interaction because the effect of one independent variable, study hours, is changing across the levels of the second, which in this case is sleep hours. So let's look at some visuals of an interaction and a no interaction in this experiment. So if the researcher ran that factorial design that I've been describing and found this outcome right here in this left bar graph, this would be no interaction, because if you look at the difference between the mean exam score of 0 hours of studying and the mean exam score for 10 hours of studying for people with 2 hours of sleep, this difference right here at the left, and you then look at the difference between the mean of 0 hours of studying and 10 hours of studying for people with 6 hours of sleep, you can see that the difference is larger for the people who had 6 hours of sleep. So when the people have had 2 hours of sleep, the difference in exam performance between 0 and 10 hours of studying is not as much. But when people have had 6 hours of sleep, it's it's steeper difference, and the gain from studying 10 hours is greater. It's more of a benefit. So this left graph right here would be called an interaction. So if the researcher got this outcome right here in this bar graph, the researcher would say that the data is showing an interaction because the effect of study hours is changing across the levels of sleep. It's changing from a smaller effect to a larger effect. So in this left bar graph, like I said, the effect of study hours is changing from a smaller effect to a larger effect across the levels of sleep. And that would fit this definition of an interaction. And I said if the data is showing an interaction, the lines are not parallel. And so here I'm not showing a line graph, I'm showing it as a bar graph, but you can still see what I mean if you look closely at these bars. So imagine imagine at the left end, at 2 hours of sleep, imagine a line connecting these two means of 0 and 10 hours of studying. And at the right end, for 6 hours of sleep, imagine a line connecting the mean of 0, and the mean of 10 hours of studying. So basically one line connecting these two bars at the left and one line connecting these two bars at the right. If you drew those bars, if you drew those lines, you would see that this line is less steep and this line is steeper, and the lines would not be parallel, and you would see an interaction. Now what I actually did down here at the bottom left is I redrew this bar graph as a line graph so that you actually can see the non-parallel lines and see that there's an interaction. So the interaction pops out a lot more when it's a line graph. But I also wanted to help you see it in a bar graph as well. So down here at the bottom left, the steeper line is the effect of studying for 6 hours of sleep, and the less steep line is the effect of studying for 2 hours of sleep. So we have a 6-hour line and a 2-hour line. So each level of sleep has its own line down here. So when you go from 0, well, in this imaginary result right here, when you go from 0 hours of studying to 10 hours of studying, there's more of a gain when it's 6 hours of sleep and less of a gain when it's 2 hours of sleep. Now, if the researcher got this outcome over here at the right, and this bar graph ended up being the outcome, the researcher would say that the data is showing no interaction. So that's because if you look at the difference in performance between 0 and 10 hours of studying with 2 hours of sleep, and compare it to the difference between 0 and 10 hours of studying with 6 hours of sleep, you would see that the effect of studying doesn't change. It's the same regardless of how much sleep the participants are getting, because this jump right here at the left end is the same as this jump at the right end. So this outcome right here would be no interaction because the effect of studying is staying the same when you go from 2 hours to 6 hours of sleep. So in this case, in this bar graph, the effect of studying is not changing across the levels of sleep, which would make it no interaction. And if you took this bar graph right here and turned it into a line graph, it would look like this, and the lines would be parallel. And you could, once again, it would pop out that there's no interaction because you could easily see that the lines are parallel. You could see that the 2-hour line matches the 6-hour line, and you could see that the gain in exam performance from studying 10 hours is the same gain no matter how much sleep the people are getting. So so here you can see interaction versus no interaction visually, and make sure to keep in mind that the interaction is when the lines are not parallel, and no interaction is when the lines are parallel, because that is the simplest way to remember the difference. Now, I'd like for you to understand this concept at a deeper level than just remembering if the lines are parallel or not parallel, but that's an easy way to remember the difference. And before moving on, I'd like to talk a little bit about where this word interaction comes from. I'm not exactly sure how this word was invented, but I'd like to just share my thoughts on where the term might have come from or what it means to me. So when I think about this word interaction, what I think of is that a second independent variable is interacting with the effect of the first independent variable. So in this case, the sleep hours is interacting with the effect of study hours, because sleep hours is basically changing the effect of study hours. Because when sleep goes from 2 to 6 hours, that causes the effect of studying to become larger. So it's kind of like sleep hours is messing with the effect of study hours. And that's what I mean by when I say it's interacting with it. So if a third variable interacts with the effect of one variable on another, it's an interaction. Another way to think about it is it's when the effect of A on B depends on C, a third variable. In this case, in this imaginary result, at the left end, the effect of studying on exam performance depends on sleep. The effect of A on B depends on C. So now I'd like to share a few other examples of interactions from everyday life, just so you can look at as many examples as possible, or at least a few, to help you get this idea down. We know that in general, work hours has an effect on earnings or income, because when your hours of work goes up, that in general, or in a lot of cases, that causes your income to go up. Well, if you're earning an hourly wage, then increasing your work hours does cause your income to go up. It does have an effect. But if you broke it down and can compare and looked at the effect of work hours on income for people earning a higher wage, and you then looked at the effect of work hours on income for people earning a lower wage, you would see that the effect is steeper for people earning a higher wage. So this line right here might be people earning $100 an hour, and this line down here is people earning $20 an hour. So if you're earning $100 an hour, your income is going to go up much more by working 10 extra hours a week. And if you're only earning $20 an hour, your income isn't going to go up as much if you go from 10 hours to 20 hours a week of work. So, and this would make non-parallel lines, and it would be an interaction. So in this case, you could say that hourly wage interacts with the effect of work hours on income. And so it might help to connect the idea of an interaction back to the idea of a correlation. So if we were just looking at one line right here and it was rising, you would say that that's a positive correlation. So a correlation is just a relationship between two variables. But if you break it down into two separate lines, one line for one situation and another line for a different situation, and you see that the line changes, and you see that the relationship in one situation is different than the relationship in the other situation, that's when you have an interaction. So another way to think about it is an interaction is when a relationship between two variables, like a correlation, changes from one situation to another, either by becoming more steep or less steep, or even by switching directions. So if a relationship is positive in one situation and negative in another situation, that would be an interaction with non-parallel lines as well. If you had a graph in which one line, if the line went up in one situation and went down in the other situation, that would be an interaction. Now let's look at one other situation. Here I'm showing you that food intake, or the extent to which a person's stomach is full, interacts with the effect of alcohol on intoxication. So the fullness of a person's stomach changes the effect of alcohol. So, like I said, the fullness of a person's stomach interacts with the effect that alcohol has on intoxication, because if it's an empty stomach, alcohol will have a stronger effect, and if it's a full stomach, alcohol will have a weaker effect, and that makes an interaction right here. So this y-axis is intoxication. Here's an example from social psychology, and this example is something called social facilitation. You might have heard of that before from a social psychology class. So social facilitation has to do with the effect that an observer or a spectator has on some type of task that a person is performing, like it could be basketball, golf, or anything that could be observed by a spectator. What researchers have found is that when the task is easy, an observer is helpful and leads to higher performance, but if it's a difficult task, the observer is actually harmful, the spectator is harmful, and the person will do worse when being observed. And this is another interaction because when the task is easy, performance goes up when there's an observer, and when it's a difficult task, performance goes down when there's an observer. And the theory behind this is that when a spectator is present, that causes the person who's doing the task to feel more aroused, to feel a higher level of arousal because of the fact that they know that they're being watched. And if the task is easy, that arousal is going to benefit the person and help them do better. But if it's a difficult task, the person is already under a lot of pressure and stressed, and the stress, the arousal that's caused by the spectator will create an overload and cause the person to choke basically at the task. So here's an interaction in which the lines actually move in separate directions. So it's a positive line in one situation and a negative line in the other. So before we move on, I once again want to connect what you're learning now to what you learned before earlier in this class. Back when we were talking about correlational research, or when we were just beginning to talk about correlational research, we learned that a researcher collects a data set, looks at a correlation by either making a scatter plot or by calculating a correlation coefficient, and the correlation is what it is. It's positive, negative, or nothing. And then at that point, that's the end of the road. The researcher stops there. But here what you're learning is that if a researcher finds, if there's a relationship that's, let's say, positive or negative, that's not the end of the road, because the researcher could go and investigate the topic further and find that the relationship actually depends on another variable, and that the relationship actually changes from one situation to another, and an interaction is actually present. So you can think of it that way. Knowing that a relationship or correlation exists isn't the end of the road, because you can always go further and see if another variable interacts with that relationship. Sorry, I had to move things in a little bit just to make this slide fit on the screen. But now what I'm showing you are some different examples of no interaction and different examples of interaction. So just visual examples showing you that the different ways that no interaction could appear and the different ways that an interaction could appear. So there's really only 3 ways to have no interaction. Either the lines are parallel and they're both rising, the lines are parallel and they're both flat, or the lines are parallel and they're both decreasing. These are the 3 ways to have no interaction. And notice how in all 3 of them the lines are parallel. And there's actually many ways to have an interaction. There's actually no limit to the number of ways an interaction could look like. But I'm just put a few here to highlight. So any line graph with 2 lines that are non-parallel is an interaction. And you can probably imagine how there's many different ways to have non-parallel lines. You could have something like this in which one line is flat and one line rises. You could have 2 lines rising and one is steeper than the other. You could have one line rising and one line decreasing but they're equally steep. You could have an X. You could also have something in which one line is flat and the other line crosses through it like this. You could have a graph in which the top line is flat and the bottom line decreases from left to right. And it's just this graph turned around 180 degrees. So there's many ways to have an interaction, but these are the few that I'd like to highlight. And before wrapping up this video, I'd like to bring up the idea of a drug interaction, because I think you might be familiar with that, and I think that would help you connect this concept to something that you already understand. Here I just made 3 examples of drug interactions. They're just 3 visual examples that I decided to highlight visually. So here we have an interaction in which drug A These are just a few visuals that I decided to show you, just to help you get the idea of a drug interaction down and how it's just a specific example of an interaction. At the left end, we have a interaction in which drug A has an effect when drug B is not taken, and when drug B is taken, drug A has no effect. So drug B cancels out the effect of drug A and makes drug A useless or have no effect. In the middle, we have an interaction in which drug A always has some effect, but the effect is steeper. Drug A has more of an effect when drug B is taken along with it. At the right end, we have an interaction in which drug B actually reverses the effect of drug A. So if drug B is taken, drug A has this effect going downward, and if drug B is not taken, drug A has the opposite effect on the person. And help you see how a drug interaction is just a type of interaction, and this might help you connect the concept of interaction with something that you already understand. It's helpful when you learn a new concept to connect it with something you already understand, because then you're taking a complex concept and connecting it to something that's more familiar.